Good morning, everyone. I hope my voice is coming through. Just double checking if somebody can give me a sign that I'm...
Yes, you're live.
I'm live. Super good. All right. Today is a concrete day. And as promised, we will talk about different concrete fasteners. And I will do a very light introduction. Today's main speaker is Victor. He's our commercial product manager. And the agenda is like usual. We do a light intro for those who are new, and then we go forward with our, let's say, case study. From the business idea, in Nordic, we are available in 1,100 different retailers area. We are founded in 1970. We have our so-called branch offices in 7 countries, total 200 employees, and we belong to the permanent payment group. Cool message is that we sell roughly 5 million ESSVE screws every day. Today's subject, like always, we talk about foundation and structures, but we go more in the bottom here, not in a timber, but this time in concrete structure and installation areas. So maybe a light introduction as well on technical expert here. Radek is our best person who will help you on demos in Eastern markets. If you are, of course, we are willing to come and visit you. As mentioned, Victor is our product manager, and I'm in sales, technically supporting. Software is available. Find it out. Hopefully you have already tested. And I'm not going to speak any longer. I'm just been self in fastener business roughly 25 years. So all open questions in the end are welcome, either one mutually or written way. But here we go. Victor, you as our senior developer and experienced engineer on product management, go ahead and floor is yours.
Yes, thank you. So I will start by sharing my screen and start presenting. Do you see the correct green slide with the product?
I see the range of product now.
Yes, so we will do a brief introduction to the products that can be found in the software, and then we'll talk a bit about the software afterwards. So first of all, we have the classic wedge anchors there on the left side, and these have existed for a very long time in the market, primarily intended to fasten steel to concrete, I would say, and we offer them in carbon steel and in stainless version, and in a lot of lengths and dimensions. Next, concrete screws we think are perhaps a bit more modern product, and here we talk about, of course, concrete screws that don't need a wall plug. They can be installed directly into the concrete after drilling, of course, and it's very easy to install compared to all other concrete fasteners, I would say. So easy installation and also easy to remove, which is good from a sustainability point of view in terms of when the building will no longer be used in the future. And also some dimensions in our EUS2 range are suitable for temporary installations, but that's a bit of a special application where you test the screw after each used for instance, for safety railings and such things, and then you check the thread how many times you can reuse it. But typically you can reuse it quite a lot before the thread wears down. But it's hard to give an exact number, and that's why you need to check the thread before installation. And this concrete screw are also in general more suited for installing in timber. Also works for fastening steel to concrete, but it's better than wedge anchors for fastening timber to concrete. And we also have chemical mortars. They're very flexible, so they can be used in basically all the possible materials, not just concrete, but also hollow bricks and solid bricks, lightweight concrete, and so forth. And you have a very high flexibility in terms of the steel you use. You can, of course, use 5.8 graded carbon steel, 8.8 graded carbon steel, and so forth, as well as stainless steels of various steel grades. And a wide range in terms of the metric dimensions, so M8 to M30, or if you want to use rebars. So very, very high flexibility in terms of installation. And it also prevents, of course, water to accumulate in the hole, since you block the hole with the chemical mortar. And the only big downside is that it's quite complicated to install. I would say it takes a long time, because you have to clean the hole very properly, remove the dust to actually get this load capacity. And of course, the deeper you drill the hole, and it's the more difficult, so to say, it becomes to clean the hole in a good way. So that's something to keep in mind. So it's a good product, but if it's not needed, then it will complicate things in the installation point of view. And last of all, we have the drop-in anchors that are more special use, perhaps, but suitable for when you need a shallow embedment in the concrete. You don't want to hit the rebar, for instance, or if you have thin concrete members or hollow core slabs, can also work. Usually used in temporary installation for like diamond drilling and such, or in suspended ceilings. So that's a little bit about the products we have. And a service we offer is, of course, pull-out testing. A lot of the time, especially when you do a testing tension, it's not the steel that will fail, but it will be the base material that is the weakest part of the fastening, so to say. So here you can actually check what will be the capacity of the anchor based on that. I would say it's mostly useful in those lightweight concrete or bricks, and less useful in pure steel. But it is a service we offer locally, so contact customer service. And also shear testing is something we have started to offer, so far only in the Estonian market, but this will become available in other markets in the future, if that's of interest. Then another product I want to mention, it's not in our software, but it's a very good product specifically for lightweight concrete. So this is a product that we actually do a lot of pull-out testing with, and the capacity is very good in solid bricks or of lightweight concrete. It becomes very similar to the capacity that chemical mortars have, because of course, again, it's the base material that is the weakest, so not the steel in the screw. And this is also covered by a CE marking and an ETA for the long setting depth, so 100 millimeters and 160 millimeters is required for that. And then a little bit about the concrete screw that I already mentioned. It has a wide range of applications, of course, permanent installations in cracked, non-cracked concrete, also in hollow core slabs that we show in the picture here below. And then there you actually want to install it in the hole, so you don't hit the rebar on the sides there, the black dots. And yeah, we'll talk a bit more about this product when we go into the software, so to say. But we also have this reusability, what I mentioned with the sleeve, that you can test the thread, see if it's still usable, and then you can use it again for temporary installations, such as those safety rails and bracings, for instance, if you're setting up walls of the building. So now we'll start going in a bit on the software. And it's a free download, so it's a desktop software, but it's very, I would say, intuitive, and it's easy to use. I will show that. You always get a confirmation from the software. Is this working or is it not working? And if it's not working, then what's the reason? And I will show that very quickly, so I will not talk more here. I think the easiest way to find the software is actually to click through our on our website, and you want to go to our concrete page for engineers, for designers. That's available on our local sites here. And the design in this software follows the Eurocode. This is the first generation Eurocode, but it was actually published quite late. It was published in 2018, and it's the design of fastenings for use in concrete. And this Eurocode is very similar to the previous methods that were available for evaluation. That was the ETAG methods and various IOTA documents. And then for a while, we also had the CNTS, like technical specifications that were very similar to the Eurocode. Small differences that are described in the standard for those that are curious. So how does this Eurocode work? Well, it looks at all the different failure modes for, first of all, intention. And like I mentioned, of course, steel is a failure mode, but it's usually not the one that occurs for fasteners. More common is the one that's B here. So that's a concrete cone. So you basically pull out a large chunk of the concrete. Another quite common failure is the pull-out. So essentially, the fastener is pulled out and there's just a hole left. So actually the concrete is like strong enough, but there's a local failure somewhere around the fastener, so it's pulled out. And then D is a special variant of that with bonded, which is the chemical anchors. And then E is a splitting failure. Splitting is like when you have a small concrete, not a slab then, but more like a brick type size of concrete, then it can actually split. So basically the concrete would split in half, so to say. And so that's not so common for concrete, but it's available as a failure mode if you have a small dimension on the concrete. And then another special case is this blowout, the F. That's also, a special geometric requirements. Basically has to be valid for that to happen. So it's not so common either. And then on the shear side, here actually steel is more common as a failure mode, and also if it's installed close to an edge, it will definitely be a concrete edge failure. So that would be D. And can be important to mention here that when you have a shear load, it counts from the, what do you call it? What do you say? Like the flush with the concrete surface. So if you have the force acting higher up on the anchor, you actually get a bending moment on the anchor itself, and that reduces the capacity quite a lot. And this can also be accounted for in ESSVE CS, but in special situations. So the most common situation is that you actually have the shear load on the plate, and I will jump forward. Another important thing to keep in mind when you design is the cracked and not cracked concrete. And this is described also in the Eurocode, like how do you assess if the concrete can be considered uncracked. But the safe side is, of course, to assume that it's cracked and this evaluation method that's in the Eurocode, yeah, you need to have like high compression basically, and then it can be considered uncracked. But if you're uncertain, it is always conservative to assume that it is cracked and that the concrete is in tension. And this, as the Eurocode points out, considers the full service life of the fastening and the construction, not what it looks like when you install the anchor. It's the zone in this building in tension. That's the important question that you need to answer. Unfortunately, here ESSVE CS doesn't help you in any way to determine this. It's just a design option that you have to consider in the software, if it's cracked or not cracked. And then some, I would say, common questions that we get, like why can't my connection look like this? And in the software, and that is because the software follows the Eurocode very closely here. Like these are the patterns, so to say, that the Eurocode allows. So that's what we can do in the software. And does the software support timber to concrete connections? And then no, not fully, unfortunately. The Eurocode is written very much that it's a steel plate that helps distributing the forces down to the anchors, and that the anchors are loaded very symmetrically, or they have a combined effect thanks to the steel plate. So if you want to do a design for timber, you have to check the timber side, so to say, of the fastener with head pull through, for instance, or shear on the timber side of the fastener. And then there's just a quick mention that load tables are of course nice, but they have their limitation, and we will look at some of those limitations today. Often you see in almost all load tables, not just the ones from ESSVE, that you don't consider edge and spacing effects. So it's just a single anchor, and it's infinite concrete slab in a way. And it's usually also a pure tension load or a pure shear load. So it's not a combined loading. If you have both a little bit of tension and a little bit of shear, that's a bit not directly accounted for in the load tables. And then in our concrete screw that I mentioned, so we have this tension and shear. We actually also have shear when you put it at the smallest edge distance. So there you can see that you have a very large drop in the capacity if you install it very close to the edge. And we also have load tables for hollow core slabs. These are not in the software, but they're like kind of easy in a way to evaluate, since you're like kind of limited in how to install it, and then just follow the spacing distances, and you're like good to go. So the software is more for when you have a plate that you want to design properly, I would say. Same with temporary installations. It's just you have a capacity and just follow the spacings, and it's fine, so to say. So now we'll jump out of the presentation and we'll go into the software. And when you start the software, it will look maybe perhaps more like this. So the first thing that I like to check is, okay, what evaluation method am I using? So now I'm using this Eurocode method. And another important thing is in the base material, like what base material am I using? And here I'm using cracked. So that's good because that's on the safe side. And we will look at a concrete screw, I think, and we will look at this one. And as you can see, we have 4 anchors currently, but we will start by looking at a single anchor. So oops, we'll change here that we have a single anchor. And we'll start by applying a shear load. We're doing 21. And then you can see here I added 21, and then you actually see on the arrow, like now the direction of the force is going here from left to right. If you want, you can click the arrow. So now it goes the other direction. You can also do this directly in the input. It's a bit more difficult because here you have to consider the symbol. So if it's a negative and plus, you can flip the direction like this, but we want it pointing this way. And here you can also see that we have infinite edges in all directions. So now what happens? We have a capacity of 21. That's basically full capacity. We can click on the results here, like why is that happening? Okay, we have a concrete failure. So that means it's not a steel failure, it's a pry-out failure. And what would happen if we install it closer to the edge? We can try to do 40. And then we have to look, we can see here already, like 40 is too little. We have to increase it to 50. That's actually the minimum amount for this anchor. Okay, 50. Okay, but we still have some error. The attachment protrudes from the concrete. Okay, so then we have to reduce the size of this. And now it works. So we have a much higher utilization here, 670%. So the capacity is only 3.1 kilonewton, and that was what I showed in the load table. So it's reduced dramatically for this shear load. We could also apply a tension load, but how much can we actually apply when we're utilizing so much in shear? Well, we can perhaps only add 3 kilonewton, and then we can see. No, of course, this will not work because we have the edge distance here. We'll remove this edge distance, so we go back to infinite. And then it actually doesn't work because the interaction here, we're at, you can see it here, 105%, so it's a little bit too much. You can also see it here. Here's the tension, here's the shear, and here's the combined. But if we lower this to 2, yeah, that works. So now we're at 97. And if we, of course, if we remove the shear, now we can utilize a lot more in up here. Here we're almost doing 20%. So 10 will be the actual maximum that we have in tension. So this is what you can't really get directly from the load tables. And what else can we look at? What happens when we have 2 anchors, for instance? Then of course the capacity should be doubled, and in this case we can increase it here. Of course it's fine. So why is that? Well, again, we don't have a steel failure. We're not even close to having a steel failure. It's a concrete failure. So this means it's the concrete cone that is the failure. So both of these have a concrete cone that's governing the failure. But if we put them much closer together, how close can we put them? Well, can we put them 30? That's very close. That will probably not work. No, that doesn't work. But we can actually put them at 50. Okay, so then it's still a concrete cone, but this concrete cone is now shared between the anchors. So it's like quite small for both anchors. So the capacity of 2 anchors are not doubled anymore. So if you remember from the single anchor, it's approximately 10, but now 2 anchors only have 13, almost 14 kilonewtons in capacity. And that's simply because they're installed so close together. So how close can they actually be installed to have full capacity? Well, I happen to know that it's 180. So I will input that here, and then you see I have the full 20. How can I know that it's 180? That's maybe not so easy to remember, but the setting depth of the anchor is 60. And then if it's 3 times that value, then that's the full capacity of the concrete cone, so to say. So then we have two cones actually. So it's full concrete cone is available for both anchors. So that's a little bit on the concrete screw, and then we can quickly go through what's so good about chemical anchors, because as you can see here, like with the concrete screw, and we are a bit limited. Like in this dimension 10, we have 3 possible setting depths, the 60, 43, and 68. So we're kind of limited if we have a very high load. So again, we switch to one single anchor and say we have a load of 50 kilonewton. Then that's very high for all of our mechanical fasteners. But if we go to the chemical anchor, we have various different types of steel grade here, but we can try hot dip galvanized 5.8. Will it work? If we pick the M16, for instance, or M20, it doesn't seem to work. So why doesn't it? Like here, the tension load is 111. So what's the failure? It's not the steel, so it's concrete, but we know that this anchor, we could put it deeper than 150. So what's limiting us? Well, in this case, it's the actual thickness of the slab. So if we increase the thickness, and then we have to click, oops, we could have tried this in a different way also, but sorry. Why is this not going away? Seems to have got a bit stuck. Did we?
Here you have raised a hand there.
Yeah, I think if you reduce the load, Victor, so because 50 kilonewton is too high for one.
Yeah, but it's I know what you mean, but maybe it is too high. It's a bit weird that it doesn't show. Now it works. Yeah, but it should have shown the error. Okay, but it works with 40. What I wanted to show was that it increases the setting depth. Now it has become very fixed, so it doesn't increase it, because we have the possibility to put it at 400, and now we only have 50 capacity. So then we could do the 50. So that should update. I don't know why it crashed a bit here. Maybe I need to restart the software, but it should be more flexible than it was in this little demo. Now when no, it's still locked. Oh. Okay, but that's basically all I wanted to show. We actually have a little bit time left, so we can do one more thing. So we jump back to 4 anchors. We increase the spacing here to, oh no, not 400, 100 maybe it's fine. Then we have to make the plate bigger. Oops. 200. We'll remove this. And we'll add a bending moment instead. So then this bending moment has to be taken by a force couple. So 2 of the fasteners are being pulled, and then the plate is being pushed on the other side. If you, oh no, okay. Thought we would be able to. feel like so. I will need to restart my software. Something is not working as intended with the chemical anchors, unfortunately. Okay, but that's all for the demo. And so if there's any questions, you're allowed to ask them. SDR is raising his hand.
Yes, you can add to that because you have ability to check the steel plate too if you click on the now.
Yeah. I know that's what I wanted to show, but I think I need to restart this. It's not cooperating completely.
Are you planning to show another opportunity, or we are close to the time as well?
We're close to the time. I can, if I quickly manage to. I think it's because I removed the profile. Actually, I think that was the reason. But now we can do this simple finite element calculation to see if the load applied needs a thicker plate. But now it works with a 10mm plate, but we could have, if we only had 2mm, for instance. It tells us to adopt a 10mm thickness. So that was just it. So this is also available as a feature in the software. But now the demo is complete.
Okay. Yeah, well, I'm looking in the chat field, and actually I don't see at the moment any questions in the chat area. If you will have some questions, go ahead and raise it. Just this year is ending, Christmas is coming. I'm just informing that the next one is January 14th. Then we talk about ESSVE sample lateral connection versus metal angle bracket. And before anybody leaves, I like to also raise your feedback question related, let's say, ESSVE website, and you can just easily rate, is it easy to find technical info on ESSVE website, or is it not so easy? So you can feel free and rate it. And there is another question as well. So when you click it arrow on a button, then you can have another question as well. How well you know ESSVE concrete product range overall. So if that's not so difficult to give the feedback, we are very happy to get it from you. So looking forward to your feedbacks. And what can I say? See you on 14th. If there is no other questions, I will look at the chat as well. Is there anything on the chat have arrived in? No, nothing at the moment. But the feedback is slowly rising at the moment. To find website is on a 0.4.3, and when we talk about to knowing ESSVE concrete range, we are in level of 3.5 at the moment. So you can give us that feedback. Otherwise, we have get over the time. Now it's 10:33. I thank you very much. And once again, here are our so-called Eastern contacts with Victor as a product manager. If you wanted to raise any questions, you can send us an email or be open asking us to make a visit and talk about products, helping you on projects and so on. But this is it from my side, and thank you very much, Victor, for presenting it.
Thank you.
I wish you all a good Christmas and year-end coming.
Bye-bye.
Bye-bye.